So let me take a body, and the Earth is spinning about its own axis. So this is a North Pole. This is South Pole, and let R be the radius of this. Let it make an angle theta. I kept it here. Now what are the forces that are acting? First, the weight due to acceleration due to gravity. And how do that will act? Should be like this. Don't show mg vertically. So I think in fourth standard you'll be introduced to the geography, planets, it's spherical in shape. I got scared because the moment the teacher said like our planet is spherical in shape, then so what happened? A fear came in me that so if I'm here, no problem. So as I move starting here, so I'll fall down, and if I'm here, what will happen? I will fall. This what no here how the weight will act. If we keep object here, how weight will act? The weight will act like this, m1g. If an object is kept here, m2g. If an object is kept here, m3g. Am I right? And if an object is kept here, don't show m4g like this. Huh? We are in a gravitation chapter. The gravitational force will be acting like this. Able to understand? I think in the fourth standard or something, will when teacher introduces to geography, the moment spherical in shape, then gone. I was really scared that we should never go to Australia, New Zealand. There, what happened? We will slide down because Australia, New Zealand, somewhere it's come here. We may fall down. Okay, we should be somewhere in this region. Then I started looking at the globe. We went to the like a lab there. Then we look into the Earth. Where is our planet Earth? Oh, okay, planet Earth is here. Then why we are somewhere almost here? Why we are not sliding? These were the things. What thoughts I had. Almost some 3-4 days I was really scared. Then the next question came. Okay, what is here? Why this water will not fall? Okay, this water here, what happened? Okay, then the Antarctica is there. Why that ice will not fall down? So these were the things which were really troubling me a lot. That one, because at that time, who knows that? Because what is our assumption? Earth is flat, no? All of a sudden, spherical in shape means. Then we thought like, okay, then most of not only me, some 2-3 my friends all. Then we went on to top of the building. Some mountain hill was there nearby our house, so we climbed up. Then we saw, okay, where is the spherical? We are seeing everything flat. So many things will come. See, there's what we should observe the nature. That fast we are forgetting that one. We are not observing nature. We are observing only in books. Science is not about in the books. And unless you come out of the book world, no, learning science not possible. Okay, let's come for this one. So the mg, okay, fine, justified. It should not show vertically down. It should act towards the center of the earth. Then what about the pseudo force? The pseudo force here. Okay, this distance. Let me take x here. The resultant of these two is what? The actual weight, no, effective weight, or g dash is what we can call it. So what is theta? Theta, I'll call it as latitude. This theta is called as a latitude. So when an object is kept at a latitude theta, then what is the effective g? So g dash is equal to g square. So these are the two accelerations are there. Omega square x is one acceleration, g is one acceleration. So then this should be equal to whole square plus 2g omega x cos of, what is the angle between them? 180 minus theta. These are the two vectors I'm taking. So if you're getting confusion, you do one thing. Write g, this you write it, say g1, sorry, g you write it, or this you write it, g omega. What all that acceleration due to rotation motion of the earth. Sir, why you're not taking m? I think the effective weight, the m, everything will get eliminated here. And now what is usually omega? Anybody? Omega? What is omega? 2 pi. What is the time? 24 hours, no? So 24 hours. So what do you expect this omega? Very, very small, no? 24 hours, 24 into 3600. How much of time it will take for the Earth to rotate about its own, to make one revolution about its own axis? 1 day, no? So what do you expect the omega? So, sir, not getting, you do one thing, stand in your home, stand in one room. You take 1 day to go to rotate about your vertical axis passing through your head. You take 1 day, then definitely what is your omega? Very, very, very small, no? So therefore this will become negligible. G square 2g, I think this will become minus cos theta. G dash is equal to the power of 1 by 2. Let me express everything in terms of g. So I'll take one g outside, g square outside, then it'll become g 1 minus 2 omega square cos theta by g. Omega square x is missing. Okay, this much with it. So let's find what is omega square. So this quantity will be small. Binomial expansion, it will become omega square x cos theta by g. 1 by 2 and 2, that will get eliminated. What is x? X is what we assume, no? In fact, theta is a latitude. So what is cos theta? Will be x equal to r cos theta. Let me substitute that. G dash is equal to x equal to r cos theta. R cos theta by g. So I'll g minus omega square r cos square theta. Okay, this is one best formula. As you just vary the latitude, you are going to get the effective g due to the rotation at the equator. What is value of theta at the equator? At equator, theta will be 0 degrees. This is 0 degree line. This is theta equal 90 degree line. So at equator, g dash will be g minus omega square r. You do have one very good problem in SU Verma. Train moving is telling. So the train will also have a speed. Due to that speed also, there will be a centripetal force. Do work out. It's a very good problem. So this is the effect of the rotation at equator. What about at pole? At pole, what is the theta? Theta will be 90, no? At pole, what happened? Due to rotational effect, the rotational effect will not have any influence when you measure